Welcome to today's video on Cambridge IGCSE Mathematics 0607 and 0580. The topic for today is coordinate geometry, where we will be focusing on the subtopic linear programming. To start off with, we're going to first go ahead and introduce ourselves to the Cartesian plane. In a Cartesian plane, we have two separate sets of number lines that have been drawn. These number lines have been placed perpendicular to each other, and we label the horizontal line as x, and this is called our x-axis, and the vertical one is going to be called as our y-axis. Now, we can also have a third axis, that's the z-axis, and when we do have that third axis, we would be able to plot a three-dimensional graph instead of the two-dimensional graph that we would be able to get with just these two, the x and y axes. When we have the x and y axes, we can represent data as points, and these points are called a coordinate. When we have a coordinate, the coordinate has a specific format that we denote it in and that we give it in. And our coordinates are always begin with the x value and then followed by the y value. And our coordinates are always written within brackets and separated by a single comma. In addition, exactly where your x and y axes intersect, this is the plot that we call the origin of our graph. And this is always going to be the coordinate 0, 0. Now, if I look at these axes here and I just go ahead and label them, and I do the same for my y-axis as well, and I label them, then the coordinate that they've given us here, marked with this x here, then this is a coordinate 2, 1. And I can see the first number is my x coordinate, that's 2. And the second number is my y coordinate, that's 1. And I've put these within brackets separated by a single comma, which is a standard way of denoting any coordinate that we might have. We can also represent inequalities on a Cartesian plane. But before we get to that, we're just going to refresh our knowledge on how we can draw inequalities and denote inequalities using number lines. Now, inequalities have greater than or less than or greater than or equals to or less than or equals to signs in them. And if we see these signs in an expression, it means that this is an inequality. Now, looking at the inequality that they've given us here, we have x is greater than or equals to 5. And what this means is x is a variable that can take the value of 5 or any number that's greater than 5. And if I wanted to show that on a number line, I'll first go ahead and sketch a number line. And I would plot a solid circle at 5. Then I would show an arrow that's pointing at the numbers that are greater than 5. In this case, an arrow that's pointing towards the right. Similarly, if I instead had x is greater than 5, so you can see the difference here is this is x is greater than or equals to, and this is just x is greater than 5, which means x can be values greater than 5, but it's definitely not 5. In this case, I'll do the exact same thing where I would plot a number line with my arrow that's facing towards the right. But when I plot my circle, I'm not going to make it a solid circle. I'm just going to show the outline of the circle without shading this in. And then this is going to show us the inequality where x is greater than 5. Let's also go ahead and do another example on this. What if I had the inequality x is less than 2? If I wanted to show x is less than 2, then I would draw the outline of a circle at 2, and then I would have my arrow pointing towards the left, showing the values that are less than 2. On the other hand, what if I had the inequality x is greater than or equals to -1? Then what I'll do is I'll start off the same way. I'm going to draw a circle at -1. In this case, I'm going to shade in the circle because it's greater than or equals to. And then I would draw my arrow pointing at the numbers that are greater than -1. In this case, the numbers that are towards the right of -1. So when we look at linear inequalities, inequalities basically represent an interval or range that follows a certain condition. If this condition is a linear expression, where linear basically means that your variables, your x, your y, your z, has the highest power of just 1. So you would not be seeing terms like x squared or y squared inside your inequality. So if it lacks these higher powers and the highest power that you can see is just 1, then we can call this a linear expression. When we deal with linear inequalities in coordinate geometry, these inequalities are defined by an x and a y, and these represent the x coordinates and the y coordinates of the axes. So these are some examples that we can have when we define inequalities in coordinate geometry. So this is y is greater than 5. This is x is less than or equals to 3. This is 2x minus y is greater than 2. And because we mentioned all of these will be linear inequalities, when you plot these inequalities on a graph, you're going to get perfectly straight lines. So we are also going to look at an example of performing a linear inequality on a coordinate grid. And the inequality that we've been given here is 3x plus y is greater than or equals to 1. To begin with, what I'm going to do is I'm just going to take this same inequality, but instead of writing my inequality sign, I'm going to replace it with an equal sign. And after I do this, I'm just going to go ahead and rewrite this with y as the subject of my formula instead. So if I make y the subject of this formula, I'm just going to end up with minus 3x plus 1. So y is equals to minus 3x plus 1. And then after I obtain this, what I'm going to do is I'm going to go ahead and plot the graph of y equals to minus 3x plus 1. And by looking at this, I can say that negative 3 here, this should be the gradient of my line. And positive 1 here, this should be my y-intercept. To plot this line, I'm just going to go ahead and I'm going to have to draw up a table of x and y values, and I'm going to take different x values. So I can choose 0, 1, 2, 3, and I can also choose some negative x values, maybe negative 1, negative 2, and negative 3. And for those different x values, I'm going to have to obtain the corresponding y values, which I can do by plugging in those x values into this equation. And once I've done that, I would have a set of coordinates, which I would be able to plot onto a graph, and then I would be able to connect those coordinates using a line. Now, when you draw this line, it's really important to check if you're going to be using a solid line or a dashed line. And how we would be able to tell that is by looking back at our inequality. Now, in this question, the inequality showed us a greater than or equals to sign. And because of this, we're going to be using a solid line. If, on the other hand, we did not have a greater than or equals to sign, but instead we just had a greater than sign. If we just had a greater than sign, then we would not be using a solid line, but instead, to plot our line, we would be using a dashed line like this instead. All right. And then we should be able to shape the region of the graph that is represented by this inequality. And how we can do that is using a simple method, because you're just going to rearrange the equation or rearrange this inequality like before, so that y is the subject of the formula. And when I do this, I get this minus 3x plus 1. So y is greater than or equals to minus 3x plus 1. Now, once we've made y the subject of the formula, you're going to see that this is y is taking the values that are greater than negative 3x plus 1. Now, the values that are negative 3x plus 1 is this line here, but we need the values that are greater than this, which means we would have to be shading the upper portion of our line. So we would be taking the values not below the line, we would be choosing the values that are above the line because those are the values that would be greater than negative 3x plus 1. And there we go. That is how we would perform a linear inequality on a coordinate grid. I hope you enjoyed today's session. Thank you.